Okay, we're getting ready for class now, and I'm setting up the world. Clean up my avatar. Let's get over to the classroom. Too morning for me. All right, we need to update this checklist. Let's see if I can make this work. Oh yeah. Great, all right, that's all set up. Let's go over and get my broadcast running. Looks like Ben has decided that, double broadcast, looks like Ben has decided that he's gonna teach this morning. We'll let him sit there for a minute and enjoy his delusions of grandeur. And I'm gonna set up the screen behind us. All right, make sure that size is set up right. Size is 2040 25 by 1363, so we're talking 2045 is 1022, and 1363 is going to be 650. Let's see if we can get that to play. All right, we're going to go into endless loop now. Alright, waiting for our screen to go. Let's try again. Reset that. Looks a little better. Not resolving. Let's see. YouTube, embed, autoplay. Let's make sure that's what we've got broadcasting. 04 to CW. CW, that looks good. Broadcasting, okay. And autoplay equals 1. That all looks like the right address. Let's just try it one more time. Alright, trying to get that screen going behind us. Not sure what's up. Let's see. Give it one more shot. Streaming fine. Just the setting just does not want to take. Let's see. It's like it's not. What's going on? Let me see here. Open the URL in the external player. Oh, that didn't work. Huh. Put two dots in there. Yep, if you don't get the website right, it's not going to work. It's not going to work. There we go. I'm now going into endless loop. All right, Ben, can I have the podium? Let Dodger wander for a sec. So, come on now. Ben is doing something. All right, as we go into broadcast crazy here, can someone in the audience confirm that you're seeing YouTube? All right, as we go into broadcast crazy here, can someone in the audience confirm that you're seeing YouTube? All right, as we go into broadcast crazy here, can someone in the audience confirm that you're seeing YouTube? Okay, good morning, everyone. I steal the podium from you? See, actually, I don't think Ben's got his VPN on, so I don't think Ben can hear us, actually. I'm not sure. All right, great. Thank you. All right, let's run through. Oh, sorry, I'm double broadcasting right now. All right, so what I'm going to do is I'm going to single broadcast for second in game. All right, single broadcast just in game. Broadcasting in YouTube. All right, switch to YouTube. I can still hear you in game if you want to make a comment, or I'm monitoring chat as well. But so we have an archived version of the class. We're going to talk also on YouTube. All right, so here we are. It is class 5. It is January 22nd. It is Friday. Feels pretty good. I know a lot of folks and friends are in quarantine or isolation from COVID. So we remember them and remember to support those folks who you know that are in that situation, however that is for your relationship. Reach out by text message or deliver them food or whatever they need. My son is one of those folks in quarantine down in VK, so I'm kind of monitoring that, generally speaking. Let's go ahead and just open in a word of prayer to remember where we derive the meaning from the work that we do. Dear Heavenly Father, thank you for a chance to learn. Man, what a privilege over the scope of history and time and geography to have an opportunity, even in a pandemic and in a weird virtual world, to reflect on things that will help us to grow and to build your kingdom. We're grateful for that. We remember the folks in our community, our collective community that are sick and ill. Pray for their health, ask for insight into how we can help best support them. We also remember the health and well-being of the people in our connected communities that maybe not everyone knows, our friends and family, our parents and grandparents who are maybe scared, maybe cavalier, maybe getting vaccines, be with our healthcare workers as they help us return to some semblance of normalcy, help us to make the new normal be better than the old normal. Amen. All right, tearing up a little this morning, a little emotional about all that. Dodger, you're making too much noise. You can lay down. All right, there we go. All right. So for Ethan, who mentioned in the comments the YouTube link changes every class because of the way YouTube Live is. There is a playlist that you can bookmark though that will give you access to the to every day they get added on. But actually, when they're live, they don't end up on the playlist till after we're done. So we'll need to do that. If someone could grab the URL from the top of, oh, there you go. Thanks, Frank. Appreciate that. Okay, next thing that we are going to do is we're going to run through our calendar. Let's take a look at that real quick. So we're on January 22nd. Tomorrow, let's make sure we're looking at the right class. Yep. All right, so tomorrow you have an assignment to get your books done. Selfie a picture of your book for me. Put that selfie picture into Canvas, and that will then I will go through and grade that. So that's to make sure that you're able to get your book. Next week, we've got a programming assignment due 1 week from today for chapter 2. That's going to be using the Java object structure. You're going to create a method. You're going to import some code from a library. You're going to use return values, and you're going to use arguments in order to do a couple small tasks, simple self-contained tasks. The Wednesday beforehand, a little less than a week, you've got a review of chapter 2 through a chapter 2 techne. And I'm going to throw up a course policies quiz if that hasn't gone live yet. And what I would like you to do for the course policies quiz is to go through and just do a read through everything in the welcome section. I feel like our coverage of the course policies was a little bit spotty. So I'd like you to go back through and just, rather than spending class time doing that, read through each of the pages on our welcome assignment and make sure that you know what the course policies are. And we'll just do a simple comprehension quiz to make sure you've covered that. There will also be a get to know you quiz that goes live, and that's like a survey just asking you some questions about your background and current situation so they can get to know who you all are collectively as a class a little bit better. Both of those things will be private just for my consumption. I might report on aggregate stuff, but I certainly won't call you out individually with your answers. Okay, that's what's going on with the class, what's coming up. We're currently in chapter 2. Make sure you're reading that in your off time. I want to, in class, point out something to you. So if you, something I've added is if you come over here, you can come over if you want, or I'll show you on screen as well. Let me transition up there. Up in front of the class, I put a bookshelf over here, over by Dodger, and down at the bottom, there are 3 documents. And if you click on those documents, you will get a copy of handouts from the first episteme assignment. So zooming in there, what you can see is their solutions. So if you click on them, you'll get delivered to your avatar a solution set for Episteme 1. So as those come in, I'll try and put our solutions there so that you can come over and grab them when you need them. So that's solution set. I'll put other things there, handouts, etc. if you need them. If in class you feel like you want to get up and do that, you're welcome to do that. It would be a little bit disruptive in normal class to do that, but since we're in a virtual world, I guess that's fine. I don't know. We'll see how that works out. Walk over though. Try not to fly over. Okay, great. So broadcasting on screen the calendar, let's switch over there, and then switching on screen in YouTube to our work for today. We're on class 5, so this is in the Canvas. If you're on Canvas and you look into class 5's material, you'll see we're talking about using objects today. We have reviewed our calendars, the calendar, that was the Canvas calendar. We have just reviewed handouts, that there are handouts in class if you get them from Firestorm. The next thing that I want to do is I want to set up Saros with you. Saros is a plugin in Eclipse. And so in order to do this, you're going to have Eclipse open and running, and we're going to walk through a couple steps of setting that up. And what Saros is it's a plugin for Eclipse that enables you to write code collaboratively in the same way that you can write essays collaboratively on Google Docs, or the way you can edit a Google Sheets collaboratively, where multiple people are editing the same document. Eclipse has a plugin so that you can edit code simultaneously. And what I would like to be able to do is when I edit code in class, I would like for you all to be able to see that code in your own version of Eclipse rather than just watching on the screen. And an advantage to that is that you can take that code and you can copy it and you can edit it and you can run it on your own after class without having to transcribe it or cut and paste it from one place to another. Later on in class, we'll be working with more complicated code bases, and so it's helpful to be able to transfer those through Saros to some degree. An advantage of this is that you can also do this collaboration on code with other people in class. So once you have Saros installed, you can partner with other people in class and work on code collaboratively, so that if you want to work on a homework assignment in partners, that's something that's always possible to do. If you explicitly establish a partnership with someone in class, then you are able to turn in your assignments as a partner if you want. Just have one person submit the assignment and make sure that there's a header block in the top of your code that indicates both of your partners' names, and you'll both get credit for the same work. Since we're in a COVID situation, since we're working remotely, sometimes it's helpful to be able to collaborate without being in the same place, and so this is a tool to be able to do that. So let's shift gears and let me walk you through the process of how to do that. And this is going to be sort of one of those things where we have a chaotic mess while we install software. The participation for today is going to be me checking to see that you've actually signed up and gotten this to work. So so let's look at this and let's talk about it for a second. Let me shift over to Eclipse for me. All right, so I'm going to shift over to showing you Eclipse on the screen. Let's see if we can do that. Okay, we're showing Eclipse on the screen. And now we're going to zoom in. Well, let's leave it like that for a second. Okay, so on my version of Eclipse, you'll see down here at the bottom that I have got a tab open that says Saros. Saros, this little tab down here, is something that you can move around in different constructions of how you lay out your windows. But it is the place where you see the collaboration center. It shows who of my contacts are online, and it shows whether or not I am currently collaborating with anyone through Saros, which I'm not at the moment. Let me see if I can zoom this in a little bit so you can see it a little better. What I'm doing is I'm looking on screen to make sure that I'm broadcasting. Okay, I'm shrinking my window so you can see it a little bit without quite as so much. There we go. That's good. All right, so down here is my Saros tab. I've got no contacts logged in. I've got no session running. It's a little bit of a control center that you don't usually get when you use something like Google Docs. And let me be clear, this software has nothing actually to do with Google. The way this works is you download a plugin to Eclipse. That plugin is a little bit of code that gets added to your Eclipse installation. And when you connect with someone else, you're going to be working through a server located on our campus called VM Wardrobe. The letter V, the letter M, Wardrobe. And that server is the place where all the communication gets redirected. So when you work in Saros, the information is going to bounce through that server in order to get to one another. And it occurs to me, I hadn't thought about this till the current moment, that if you're not on campus, you're not going to be able to get to this server. If you are in game, can you, let's see, if you are, can you just stand up in game if you are not on campus? So I can kind of look around and see what we've got. right, Faith, I see Faith, you're not on campus right now. Trent, you're not on campus. Okay, that's interesting. All right, so Faith and Trent, you know what I can do is I can create a new configuration for the same VPN. Let me think. No, I can't do that because you're off campus. Let's see. Hmm. Let's see, Faith and Trent, can you elaborate a little bit on where you are? Are you in at a home or are you like in Ocean View or tell me a little bit more? Okay, let's see. Okay, so you guys, we're gonna have to figure something out. And it's probably gonna be, wow, how are we gonna do this? Let's see. It's not critical, so I think for the time being, we're just gonna let it ride, and you guys can watch the code. I'll try and get you a copy of the code. To actually share that code, I would have to set up another OpenFire server off campus. And then I would have to change our VPN to support that. All right, let me see. That's going to take a little bit of work. I'll see if I can pull that off. In the meantime, okay, so for everyone else, so Trent and Faith, you can install Saros, but you won't be able to make an account. So let's start with installing Saros. So the way we're going to do that is we're going to go under Help, and we're going to go under the Eclipse Marketplace. That's going to bring up a window of access to all these different plugins that you can get that are specifically related to writing code. Whole kinds of variety of things, some of them very technical, some of them for different languages, some of them for all kinds of stuff. And what you're going to look for is Saros. That's spelled S-A-R-O-S. Hit return in the find bar, and you should get something that looks like this. Three circles, yellow, blue, and gray. It says Saros Distributed Collaborative Editing and Pair Programming. It's open source software, so you can contribute to it if you want to volunteer and do that, and get the other people that are on the team to accept your contributions. You should see something that looks like install or um, there should be some button over here instead of installed for you that that you need in order to install it. So let me have you take a moment, install the software. I'm going to shift over to talking in game to try and work through this and see if I can work through with some of you to get this installed to make sure we don't have any glitches. So let me hit cancel, have you guys install Saros yourself. Once it's installed, you'll see something like this in the top toolbar as well. And that's where we'll go to establish a connection. All right, shifting to in-game audio. All right, I'm on YouTube. Our Saros installation did not go very smoothly because of changes to the way Saros is implemented, and we'll look into that. And also, we've got some students off campus, so that's going to require some network manipulation. In the meantime, we can carry on talking about Chapter 2 without too much ado. Great. Let's go there. All right, broadcasting on YouTube and going through Chapter 2 now. And let's go where we left off last time. Variable names. All right, so when we left off, just a brief moment, questions or comments in game before I go too far, throw them up on the chat and I will let you go. All right, Ben D, it won't let me watch the YouTube stream and hear in-game audio. Well, why don't you swing by office hours at some point? We'll see if we can debug that. You should be able to do both. You should be able to get them both because they're coming through the same audio channel. It might be a sound and media setting we need to do. Okay, so comments in Java. Comments in Java consist of two kinds. The double slash comment, which causes us to have a comment from the double slashes to the end of the line. So this is an example of that here. In this case, we have a variable that we're declaring. It's a double, meaning it's a floating point. It's a lowercase d double, which means it's a primitive type. It's not an object. It's kind of a very simple variable. And below it, we describe what that variable is supposed to mean. And we say miles per gallon, it's the average fuel efficiency of new US cars in 2011. Anything you put after this double slash is ignored by the compiler, and it's just treated as information for you to read as the person who wrote this code or someone in the future with whom you're collaborating to understand what it is you wrote. Compiler does nothing to process comments. I would say that with one caveat is that there is a markup language for comments, meaning that you can put a kind of text structure. There's a sort of syntax for comments that another program can go through and automatically write some documentation for you, and that's called JavaDoc. One word, Java DOC. It stands for Java Documentation. And so there's a way that you can write your comments so that you can produce nice PDF or HTML files driven directly from your code. Really nice, nice system. If you want a multi-line comment, you can use the slash star and the star slash to start and end a comment. And we saw how we could do that within Eclipse very quickly by using the source command, the menu at the top, source, in order to add and remove comments at various points. Okay, so we use those longer comments in order to describe what may be more complicated algorithms, to describe classes or to describe methods, and we use shorter comments typically in the body of code in order to just make quick comments to explain little bits of of what we're thinking. In this code at the bottom, you'll notice that it looks like maybe we have a mistake here at the bottom right. It looks like maybe we meant to put a comment at the end. In fact, that's not a comment, that's a division. So we're explicitly saying divide 235 and change by the variable miles per gallon. All right, we've seen the equal sign used before in multiple ways. It's also used multiple ways in Java. We don't say equals when we talk about it in the context of a programming language. We call it the assignment operator, although it's exactly the same as the equals character. Typically on an English US keyboard, it's on the upper right, paired with the plus sign. And we use that in order to move a value from the right side of your expression to the left side of your expression, to store data in a variable. So in this example here, we're taking a variable called width and we're initializing it with the value of 10. It's not working like a mathematical equal sign. It's not saying that the left and right side are the same. What it's doing is it's saying put 10 into the left, make them the same. We can also do that with the second line here, width equals 20. That's also a valid assignment statement. The only difference here is that width would have had to have been declared previously in the code for this to work. This looks like perfectly valid Python code, but it wouldn't be perfectly valid Java code unless we had declared somewhere previously what type width is. So if we pair these two yellow blocks together, both of these lines will compile without any problem. What ends up happening when we declare a variable is we create a little space in memory. For example, right here, this little block with the width present. And what we do here is we set up some space in memory and then we store a 10 in it. We set up some space in memory and we store a 20 in it. In the book, what we're going to do is we're going to use little yellow blocks to represent memory that is primitive types, and we're going to use red blocks to represent classes or objects. And that's just to differentiate the fact that they're treated slightly differently. They both store data, but they work slightly differently if they're primitive versus classes. Remember, primitives have lowercase in the type name. Classes, by convention, should use capital letters. Here's a couple more examples of assignment with some errors. So we see this first example. We are declaring a variable called height. It's a type of integer. We end the line with a semicolon. That's great. The second, we assigned int the value of height, but we're actually going to get an error here. And this is one of the benefits of having a strongly typed language like Java, is that your compiler can recognize that an error has happened here, even though that particular line of syntax doesn't seem to have any problems. You've already declared height, you're declaring width, you're using an assignment statement. But what Eclipse is able to do for reasoning here is it's able to reason about the logic that's present in your code, and it's able to see that even though you have declared height, you've never actually given it an initial value. And so if you try and assign width the value of height, you're going to have a crash because height doesn't have a value. It's just a spot in memory that's been declared but has no content in it. So you're going to get an error that says something like uninitialized variable in your code. What you want to do instead to fix that is you want to initialize your variable. So you can either do it in one line, like the second yellow block here, where we initialize it to 20, or you could have a separate line in between the two where you assign height a value. But the bottom line is that all variables have to be initialized before you're able to access them or use them in any kind of expression. The right-hand side of the assignment operator can have an expression as well. So for example, we can have a mathematical expression. And the way this is going to work is that we are going to evaluate what's on the right side of the assignment expression before we put it into width. So the assignment operator has a very low binding priority, and so all the work on the right is going to be done first. Plus binds more tightly than assignment operator, so the plus is going to be done first. The way we read this is that we read this as compute the value of height plus 10, then store that value in the variable width. Now we can have some expressions that are self-referential. So for example, it is possible to assign width the value of width plus 10. Now we just have to understand the logic of how this works, because when we do this, what we end up doing is having to evaluate the right-hand side of the expression before we put it into the left-hand side of the expression. Sorry, I'm moving windows around so the assignment operators, I'm sorry, the aspect ratio is messing up. Let me see if I can stabilize here. Good, that's where I want it. Okay. So if we look at the blue boxes, when we have the variable width, as we enter into the expression width equals width plus 10, width starts with some value, for example, 30. The first thing that we do is we figure out what 30 plus 10 is. So width plus 10, we figure that out to be 40. And then we take that value and we store it into width, replacing what was there previously. So there's a certain kind of order that happens here in order to make a statement like width equals width plus 10 work. We take the previous value of width, we add 10 to it, then we store it in width so that when we're done with this expression, width no longer has the value it had before the expression. Right-hand side is done before we do the left-hand side. Generally speaking, our assignment statements operate something like this. We have to declare our variable, for example, width being a double. We have to give it a value, so we're giving it 20. That'll get understood as 20.0. We can change the value some point in the future, and once we already have the variable declared, we no longer want to preface it with the type. We only preface it with the type one time. So for example, when we set width equal to 30, we're not saying double width equals to 30 because we've already declared the variable. Now we're just using it. And then once it has a value, we can use it on the right-hand side of the expression, width equals width plus 10. All right, let's run through a couple sort of light quiz questions here. What's wrong with the following variable declaration? Rather than trying to get us to respond, I'll just give you a second to look at it, and then I'll walk through an answer with you. All right, there's actually several things wrong with it. One thing that's wrong is it's a bad variable declaration. Miles per gallon can't have spaces in it to be a good variable declaration. That would be a good candidate for a camel case variable. Another problem is that we're assigning it a value that isn't an integer. 39.4 is a float or a double by default, and so we would prefer to have int have double on the left of it. Int should be replaced by double rather. And then finally, there's no semicolon at the end of this statement, so there's 3 errors here. Okay, how would you declare and initialize 2 variables, unit price and quantity, to contain the unit price of a single item and the number of items purchased using reasonable initial values? Okay, you probably want to dig in for a second of what I mean by reasonable initial values. And what that means is thinking about whether or not it should be a float, an integer, a string, something like that. So as we look at this and we say unit price, what that means is the price for a single thing that you're selling. So the price for a single apple, the price for a microphone at the Apple Store, a price for a bag of flour, something like that. Prices are typically floating point, so we would want to use a floating point. Quantity, however, is typically an integer. And so how many cans of Coke are you buying? You typically don't buy 2.5 cans of Coke. You buy integer values. So you might declare it like this. Unit price, a double, and initialize it with a reasonable value, $1.95. Second variable quantity, initialize it with a reasonable variable, 2. All right, what are the types of values at 0 and double quote 0 double quote? 0 is an integer if we don't have double quotes around it, and it's a string if we put quotes around it. So we treat it as characters if it's a string, and we treat it as a number if it doesn't have the string. I think this is the last one. What number type would we use for storing the area of a circle? First thing I think of in a question like this is, well, what kind of number is the area of a circle? And the main differentiator that you have to think about is whether or not it's a floating point or an integer. Circles can have fractional areas for sure, and so we're going to use a double for this. All right, which of the following are legal identifiers? And by that I mean which ones are legal variable names? Turns out that only the first 2 are. And the reason why is because greeting starts with a letter. This should be a class because it starts with a capital letter. G, because it starts with a letter, is a reasonable variable name. It's not very descriptive, but it would work. Void isn't a good variable name because void is a reserved word. So you might not know that, but you'd get an indication in Eclipse if you tried to do that. 101 Dalmatians is a bad choice because it starts with a 1. Hello World is a bad choice because it has symbols and spaces in it. And then greeting is not a good choice because it starts with a less than symbol. All right, but good. Good. All right, let's do this one quick. Declare a variable to hold your name. Use camel case in the variable name. String my name, and then initialize it to some string. Camel case is the capital N. Is 12 equals 12 a valid expression of Java language? No, because the left-hand side is not a variable. We can't assign 12 to another value. There's a number literal is not a place to store something. It's just a number. So it has to be a variable. Okay, great. So we now have the understanding of variables. We know that objects have methods. And so let's talk about how to call methods. We're going to call methods by using the dot operator. So any particular type, any particular class, for example, string, every string has the same methods that can be called in it. That's what makes a class a class. It has the same internal data. It has the same methods that can be called. So the printstream class that we've worked with, the system.out, has a couple methods that we've used, println and print. The string class has some methods that we can use, and you can do that with all string objects. So length is one of them. So in this first yellow box, you can see that we're calling length, and that's going to tell us how many characters are in that string. You call that by using the dot operator, and so that goes into the object. Dot looks into the object for the method, calls the method in the context of that variable, and returns a value. So for number of characters here, we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I counted through the characters there. I think I got that right. So that number of characters variable should get the value of 13. The length of a string is an integer. It returns an integer because you don't have fractional characters in a string. Another example of a method that you could call is toUpperCase. You can see that that is in camel case. That's built into the string class, and so we can say river variable equals Mississippi, but if we would like to have all those letters in capital, we could set up a second variable called big river that will equal river with the toUpperCase method applied to it that will return a version of Mississippi with all the letters capitalized. In Python, we talked about the public interface being those methods that a user of a class can access. And we contrast that to those methods that are available to the systems programmer, those that are private, those that are internal to our class. So we have the public interface and the private interface. In Python, we didn't have a way of formally separating those two roles of methods. In Python, you just were supposed to indicate which are public and which are private by the name of the method, and private methods started with an underscore character. In Java, we explicitly add some information that tells us whether a method is public or private. So for example, when you start a given class, the main method is a public method. So let me see if I can make that for us here. So let me transition. Here we go. What I'm going to do is I have a project that I already created for today, class 5, 122. And what I'm going to do is I'm going to create a new class here just so that we have something to work with. And I'll call it demo with a capital D because it's a class. I'm going to ask Eclipse to create a main method for me. And then I'm going to hit finish. It'll write that, put it in a default package, and open it for me. And then in my broadcast, I'm going to zoom in so we can see it a little bit more clearly. And you can see that the main method has been given this reserved word public, indicating that it's part of the public interface. If I want to create a new method in my demo class, I can do that. For example, maybe I'll use one that's just called mystery. So I'll have some method called mystery, and it will take no arguments, and it will return a 1 every time. All right, couple errors here. One of the reasons I have an error is because I haven't said what is the return type of the mystery method. I will give it a capital I integer return type. It could also be a lowercase I int return type. Both of those are okay. I kind of want to lean into the object-oriented version, so I'm going to have it return the capital I version. And I want to be clear and explicit that this is a method that I intend for users of the demo class to call. And so I'm going to put in front of there the reserved word public. And that both allows users of my class to call it because Java will prevent unauthorized users from calling this method, but it's also an indication to those who are reading my code that this is intended to be part of the public interface of my class. So in contrast, I could have another method, can't talk and type at the same time, that returns 0. I'll have it be an integer. And I'm going to say that this is a private method. So this is a method that's not allowed to be called by other people. And you can see that I immediately get a warning. And the warning that Eclipse tells me is, hey, why do you even have this method? Because it's never used. The warning says the method other mystery from the type demo is never used locally. And so Eclipse is telling me, hey, you might have made hey systems programmer, you might have made a mistake here because you created a private method, which is a method that's supposed to be used within the body of the demo class, but nowhere in the body of the demo class are you actually using that method. And so, as a static analysis tool, I think that you might have made a programming error. All right, well, let's say that I wanted to use that private method within my public method here, and I called it, and I'm just going to return what that private method does. And you can see that that warning on line 4 goes away because now the static analysis says, oh, you obviously know what you're doing, systems programmer, because you have called that private method. And this is okay to call that private method because who's calling that private method? A method within the class. Someone who's using my demo class would not be able to do that. So if I return, go back and say 1, I'll get that error again. All right. Checking in game to see if we've got any questions or comments about that for a moment. This will become a little bit more clear as you have a chance to write some of them. You can think about the public interface as being the controls for a particular class. So if you're thinking about your object as being a car, the public interface are the things that the driver gets to use. If the driver is like the API programmer, the driver can use the steering wheel, the driver can use the gas pedal and the brake, but the driver isn't allowed to sort of manually monkey with like the regulator inside, or isn't manually allowed to deal with the spark plug if you have a spark plug on your car. Those are things that are private methods. Those are private controls. The public interface are the things that someone who's using the car gets to work with. If the driver was allowed to manually monkey around with the spark plug, it would cause the rest of the car to not function appropriately. And that's the same thing with classes in Java. If you monkey around with the private stuff, it won't allow the public interface to work correctly. Java treats this as so critical to keep that private information, those private methods private, is that it enforces it. It won't allow an API programmer to call a private method. Python did not enforce that. Java will. Sam asks in the class, is there much reason to put a bunch of public methods in the main class? So let's see, there's a little bit of a disconnect there. When you say main class, my example didn't actually have a main, there wasn't a main class. My class was demo, and my main was a method. So maybe you could re-ask that question in a way that is consistent with either using demo, class, or main method, and then I can sort of address that a little bit better. And I'll let you do that. String class has lots of other methods besides length. Okay, so Sam says, I guess I meant the class with the main method. So is there a lot of reason to put a bunch of public methods in the class that has the main method? Okay, so let's take a look at that. Okay, so here's the class. Is there a reason to put a bunch of public methods in some class that has a main method? Depends a little bit on your architecture. So there's different ways that you can imagine putting your program together, and we haven't really gotten into it very much because we haven't really worked with any programs that have multiple classes in them. So for example, we could throw another class together called demo2. So now we have a project that has two classes, demo and demo2, and we could imagine that maybe in demo we only have a main method, and we take these public and private methods and we put them in demo2. So I'm going to slide this over to the right so that you can see it. And we can put them there. And so now I've arranged my architecture of my code in a different way. I launch my program from the demo class, and demo2 is available as a helper. And so I might be able, in my main class, I might be able to do something. Let's see if I can make this a little bigger. So in my main class, I could perhaps create, in my main, come on, there we go. In my main class, I could create a new version of demo. And then I could say maybe system.out.println demo2.mystery. So now I'm using two classes together in order to do the work that previously I could have done with one class. So whether or not you have a lot of public methods in a class that also has a main method, it depends on what you're doing. And there's not really a right answer to that question. It depends on how your architecture works. Okay, let's see. So all those public methods in the class form the interface. They form the way in which an API programmer is supposed to interact with a class. There are hidden implementations. So what happens in a public method isn't known by an API programmer, just how you call it. And so this is the idea of encapsulation. This is the idea of just abstraction. Trying to keep the details of how something works separate from the API programmer so that the API programmer can treat it abstractly. When we create objects, just like in Python, we can create multiple objects that derive from the same class. Again, if a class is a recipe, like a chocolate cake, a class is not the recipe. An object is an actual cake. The class is the recipe, but the object is the actual cake that has been made from that recipe. So in this case, we have two objects. They're both derived from the string class. And we've created them as separate items. They take up two separate spaces in memory, represented by red boxes here. They both have data instance variables, but what's being stored in them is different because they are different strings. One presumably says hello world, and the other one presumably says Mississippi. Both of these objects have access to the same methods. We can ask what the length is. We can convert it to uppercase. Same internal methods, same internal data, but they're actually carrying different, the data itself is actually different. So these things have the same behavior, but they have different actual, data. It's like saying that, you have a Honda Civic and your friend has a Honda Civic. They're both Honda Civics, but you both have your own version of it. I have an iPhone 7. I do have an iPhone 7, and let me tell you, it's got cracks all over it, and it's time for an upgrade. But yeah, I'm too cheap. All right, so I've got an iPhone 7. Someone else has an iPhone 7. They're both, you can imagine them both being derived from the same class, an iPhone 7 recipe, but they're individual objects. Each one of these objects stores its own data, but both have the same method. The methods, though, apply to the data within that particular object. This is the same mental model as how it works in Python, but perhaps you didn't totally get it when we were working through Python. So why we do it in two different languages to help you understand how objects work independently of the language that we're using to implement them. Sam, did I answer your question okay about the main method? So all of our methods have arguments to them. Arguments, sometimes called parameters. These are things that we pass in. There are values that give the method details about how we want it to do the work that has been assigned to do. For example, when we call the println method, we have to pass in the string that we actually want to have printed out. So in this yellow box, we have an example of system.out.println greeting. What that means is that we want the greeting variable printed out on the console. So while println is going to have the same behavior, print something out to the console, we use those arguments as input to the method to give it some idea of what sort of work we want it to do. Anytime println is called, it needs to be called with some kind of arguments if we want that thing to be printed out on the console. And so we call greeting, the technical term is argument, or I will also sometimes use the word parameter. All right, it's the input to the function. All right, checking in on Sam. Sam says, yeah, I was just trying to get a feel for how programs are structured in Java. Yep, and so there's a lot of different structures. Depends exactly what you're doing. All right, if an argument is the input to a method, the return value is the output of a method. So here's an example in the yellow box of a method length, which is going to return the number of characters that are in the string greeting. And the output of that, we call that method. It has no input. The input is embodied in the variable greeting. But the output is the number of characters that are being stored in the greeting variable. All right, so the methods can carry out actions. This is like a side effect. So if we call the println method, that carries out an action. It creates a side effect, but it is not a return value. So printing something out to the console changes the world. It creates some effect in the world. It creates a side effect, but it is not what println returns. I don't actually know what println returns specifically because I never use it for its return value. On the other hand, when we call the length method, that doesn't change anything in the world. It doesn't print anything out to the console. It doesn't change the contents of our greeting variable. All it does is work to return a value that we can use in some other expression. So we first evaluate greeting.length. We get the number of characters in greeting. We then move it using the assignment operator and store it into a variable called number of characters that we're both declaring and initializing in one line of code here because we're giving it a type and we're giving it an equal sign. All right. We can chain these things together. So we can immediately ask for a method to return a value, for example, greeting.length. And when that is done evaluating, we will take that inner evaluation that happens within those parentheses, and we will take the evaluation of that expression, and we will immediately chain it and pass it right into the println method. The println method will take that length as input, and it will output it to the console. And so here we are asking for a variable to have its method called length. Length will return a value as output, 3 or 10 or whatever that number is. That value will then be passed in immediately as an argument to println. Println will take that argument, will write it to the console, and then println will return something as well. It may return void. I don't even know what the value is. But you can see that in this particular line of code in the yellow box, we're not doing anything with that return value. If we were doing something with what println returned, we would have to have some kind of an assignment operator on the left-hand side of this code so that we would take the result of evaluating println and store it somewhere, but we're not doing that here. So the result of println is only the side effect of printing to the console. Lots of different methods that we have available to us. We have, for example, the replace method. The replace method is a method that's part of the string class. It's one of something like, I want to say there's like 200 plus methods that are available to us in the string class. This one is going to replace a substring with something else. So if we start with the initialization of the variable river, declare it as a string, and initialize it with the upper and lowercase string Mississippi ending with a semicolon, then in that first yellow box, we can call river.replace, which is the method. This is a method that takes two parameters, a string literal isip and another string literal our. These are two inputs to the replace function. If you read the comments for replace in the documentation for the string class, you will read that what it does is it looks for the first argument in the river variable, and it replaces an instance of the first argument with an instance of the second argument, and then returns that changed string. That changed string is the result of the replace method. We're going to take that result and we're going to store it in the river variable, overwriting the original value Mississippi with the result of calling the replace method. And so what we're going to end up with is Missouri, two states in the United States. So we're going to construct a new string by replacing all occurrences of isip with our. We're going to take that newly constructed string, store it in river. If we wanted to just immediately print that out to the console, rather than storing that value in the river variable, which is what's happening in the first yellow box, in the second yellow box, we could instead take the result of that expression, internally evaluated first because it's within parentheses, and immediately pass it to the println method, chaining the result of that method and putting it in as an argument to println, immediately printing out the result to the console and not storing it anywhere, right? It's just going to get used as an argument and then it's going to go away. All right, we are running out of time. We will pick up here next time. This idea of using arguments in a method and using the return value of those methods is the fundamental skill that we're going to exercise in the second episteme assignment. You're going to need to be able to create a new class. You're going to need to be able to work with another class as an API programmer. You're going to need to look at the documentation for that class to be able to understand how to work with that class to get the result that you want. One of the assignments is to create a program that rolls a six-sided die and outputs the result. This is a pretty standard way of getting familiar with how arguments and return values work. As a reminder, in game, we have some answers to the first programming assignments. If you want to go over them, you can do it on your own, or you can do it with me in office hours if you'd like. They are over here on the table. And let's see, what else do I need to let you know about? I think that's it. Oh, here's the thing. So for today, this is what I need to do. Okay, so for today, because attendance got screwed up because of Saros and COVID, I need to somehow take attendance for the fact that you are here. And so what I'm going to do now is in Discord, in game, I am bringing up a list of everyone who's present right now in the classroom, and I'm going to screenshot it, and I'm going to manually use that as attendance for today. You can see me doing this in YouTube. Let's make sure I did it right. I did not do it right. It's a good thing I checked. All right, I got a copy. Dodger's at the top of the list, so Dodger gets to have attendance for today. Thank you for your attention. I'm going to shift to in-game audio. I am double broadcasting in-game and on screen. Okay, shifting out of, wow, Dodgers push me around. Okay, double broadcasting. I'm shifting out of in-game audio and taking off for the day. So if you need anything, track me down on Slack.
Thank you.